Self-attention. If we are given a sentence, I see fishes by the bank, what does the word bank in the sentence refer to? Is this the financial building or the edge of a water body like river? If we get back to our sentence, we can clearly make out that the word bank in this context refers to the edge of a water body like river. But how did we find it? We just look at the word fishes. Fishes possibly swim only in a water body. That's how we find the word bank here in this context refers to the edge of a water body like river. So we just looked at the surrounding words, which is the context. Self-attention does this by contextualizing each word in a sentence. Steps in self-attention are so simple and interesting to understand. The very first step is to perform tokenization. It is simply a chopping process. We chop the large chunk into cutie chunks. In the case of sentences, the chunks are words. The words are also called as tokens. After tokenization, we get the number of tokens equal to the number of words in a particular sentence we give as input. Since computers can understand numbers only, we have to convert each tokens into a vectorized representation. For an example, if we have a word fishes, it can be converted into a vector like this. These numbers are not just numbers, they give the distinct meaning of the word. Since computers don't understand our words, we convert those words into a form the computer can go with. For this, there are many steps like word to word. We can use any of them. Thus, each tokens are converted into vectors. First of all, we have to be aware of dot product. What is the nature of it? Dot product can give the similarity extent of any two vectors. If we do a dot product between two similar vectors, the score will be high. For an example, if we do a dot product between two similar vectors like that of fish and water, the score will be high. If we do with two dissimilar vectors, the score will be very low. This is a wonderful property of dot product. Here in self-attention, we will do dot product between every pair possible. V1 will be dot product with itself and with V2 and with V3 and up to all the vectors. Similarly, each vector pair will be dot product. We can note that the dot product clearly discloses the similar words with high scores. Right now we have the dot product vector, which is a dot product of a particular word vector with itself and other possible vectors. The next step is to perform normalization. But why? We have a collection of dot products. These dot products can have large magnitudes. Normalization, such as applying softmax, ensures that the attention scores are bounded between 0 and 1, making the training process more stable and less susceptible to situations such as exploding gradients. Now, all we need to do is attention. To get the contextualized token, we follow the following equation. We weigh the original word vector with the normalized values we have, which embraces the context. The process from the dot product till the contextualization is nothing but self-attention. Here we have some jargons. Did we introduce any learnable parameters? No. Each time we'll be curious about a particular word or a vector. That word vector is nothing but the query. We check the query with other vectors, which are usually the keys. Original word vectors are weighed after calculating attention values. Those original word vectors are usually the values. Thus, self-attention makes the transformer capable of understanding the long-range dependencies.